Hello students, welcome to another class of our lecture series Physical Units and Quantities. In lecture 1 and 2 we learned about vectors and how to add two vectors and how to get the resultant. And in this lecture, after class lecture number 2, in this lecture we will just study the opposite form of it. In the lecture 2 and 1, in those lectures we studied how to add up vectors, right? Add two vectors. Now we are going to, in this lecture, resolute a vector into two parts. So let me just remind you, in the earlier lecture what we did is that, let's say this is one vector, this is vector A, this is vector A, and let's say this is vector B. Okay, this is vector B. So in the lecture 2 we studied how to add these two up. Okay, we added, what did we do? We added these two vectors. So added these two vectors and got this one and got this one. Okay, this is the resultant R, where R is equal to R vector equal to A vector plus B vector. Now we are doing the opposite process right now. Okay, so in this lecture, how to resolve a vector, we'll see how to just take this one, this is the resultant one, and split it into two and two orthogonal parts. Okay, these two are perpendicular to each other. See, so this part A, this part A, and this part B, okay, will be perpendicular to each other. So that's our study right now. So how do we do it? We do it actually very easily. That's a very easy process. So just bear with me. Right now, I am just drawing a diagram or a graph, actually, axis, two axes. This is x axis and this is y axis. Okay, so let's say this is the given vector R vector. Okay, this is the given one, this is R vector. So we need to get what? We need to get the resolutes of those. Okay, so we need to get A and B. So let's say this is A and this is B. So let me remind you again, or let's see here. If we add up this one and this one, we should get this one, right? And that's the logic. So now we are splitting it into two different vectors. So this is A and this is B. Then how do you do it? How do you do it? That's a very easy process. Remember, for any right angled triangle, let's say this is a right angle triangle. Okay, for any right angle triangle, what can we say? This is, let's say this is an angle theta. So if it's the considered angle, this is the considered angle, then this is the opposite, right? We call it the opposite. This is the adjacent, right? We call it the adjacent. And what is this? This one is hypotenuse. Hypotenuse. Now let's just do one thing. Mark it A, B, and C. Three vertices of a right angle triangle. Okay. Now we need to calculate from this one. So for calculation, I'll just copy this slide. And just, so this slide is there, don't worry about it. I just copied it and I'll just remove this one to write some calculations for this. Okay, so I'll just remove this, just give me a time, I'll do that. Okay, so now it's easy. Yeah, done. So for this triangle, if we just say what's the cosine of this considered angle theta, cosine theta. What is the cosine? See, you should remember all this from maths, right? So the cosine is the adjacent versus, divided by hypotenuse, right? So what's the adjacent here? BC. What is the hypotenuse here? The hypotenuse is AB or BA, whatever you might call it. Let's say BA. Okay. And the sine of theta is the opposite divided by the hypotenuse. What is the opposite here? AC divided by BA. Okay. Now, if we translate this one to this one here, translate this system to here, see, you might get a perfectly nice, what should we call it? A right angle triangle. Okay. So check here. Let's say this is X, this is Y, and this is Z. Okay. So now if you consider this one is the angle theta, this one, okay, which one? This one. So what do we get here? From this one we get, what do we get? Adjacent by hypotenuse. What is the adjacent here? XY. So XY is adjacent, and what is the hypotenuse here? XZ. Now there is the magic. What is XY? The value of A vector. So A, and what is the hypotenuse? The value of the resultant vector R. And right now here, what is the opposite of this theta? This one, ZY. And what is the hypotenuse? XZ. What is ZY? ZY is the value of B. See, this one and this one, these two are same. So value of B divided by what is the hypotenuse? The value of R. So what is the target? Remember, what is the target? To find out this one and this one, right? That's our target. So what's A and what's B? That's our target. So for A, what do you get? A is equal to R into cosine of theta, and B equal to R into sine of theta. See? So what is the A vector? This is the adjacent one. Okay, to get the adjacent one we need cosine of theta, and to get the opposite one we need sine theta. So remember this one, to get the, for adjacent we need to get cosine theta. See, R and R same, the difference is only between the cosine and the sine ratios, right? Triangular ratios. So for opposite you need to calculate the sine of theta. So bear with me again, because this is important for us to solve all the questions that come within this topic. Okay. So see, A is adjacent. A is adjacent to this angle. That's why this is R cosine theta. And B is opposite to this angle. B is opposite to this angle theta. That's why it is R into sine of theta. So you need to remember this one. What should we call it? A trick, maybe? Maybe you should remember this as a trick. But nothing is a trick without logic. Nothing is trick without logic, because the logic is here and you know this logic for many years. So if we try to just see how does it apply to our problems, let's say a man or a boy is pulling a cart or something by applying a force through this rope. Okay, so the force here is F. Okay, and here it is, the adjacent is theta. See, there is adjacent theta. So if we need to resolve it, then how can we resolve it? We can resolve it in two perpendicular portions. Those are perpendicular to each other. So we are resolving it, right? We are resolving it. So it is not present right now. We are resolving it. So this, if this is F and this is theta, so for adjacent, remember, adjacent is cosine of theta, okay? And the opposite is sine of theta. So this one is adjacent. See, this one is adjacent to this angle. That's why it will be F of cosine theta. And this one is opposite to this angle. That's why it is F of sine theta. See, very easy. So this one is F cosine theta. This is F sine theta. This figure is taken from one of your books. So we'll be studying all of your books or the books that are necessary for your syllabus. Okay. So don't worry about them. We'll study everything within the class only. So you don't have to worry about studying further. Now let's start solving some questions. Okay. So at an airport, a horizontal wind is blowing at 15 meters per second at an angle of 60 degree north of east. See, this is north and this is east. So if this is north, this is of course east. So the wind velocity is given here. This is 15 meters per second. Okay, and 60 degree north of east. Okay, so this is 60 degree northward from east, northwards from east. Okay, so this is 15 meters per second and this is 60 degree. Right now, how do we have to calculate the components of the wind velocity in the north and in the east directions? So in the north direction, the component will be like that, right? And in the eastern direction, the component will be like that. Okay. So we have to choose the components so that these add up to this actual one, right? So this vector and this vector should add up to this. Now, for the eastern one, see, let's say this is velocity toward east and this is velocity toward north. Now we have to see what's the adjacent and what's the opposite. See, for 15 meters per second, this one is the adjacent side, right? This one, the velocity towards east. So velocity towards east is the adjacent one. That's why it's equal to V cosine of theta. See, that's very simple. What is V? 15 meters per second. Cosine of 60 degrees. Cos 60 means root over 3 by 2. Or sorry, cos 60 means half. So it will be 7.5 meter per second. Okay, done. 7.5. Cosine of 60 means half. And what is the northern component? V. See, this one is the opposite. So this is sine theta. 15 to sine 60. Let's check it by calculator. How much is this? 15 sine 60. Your calculator needs to be in degree, of course. This is 12.99 or 13 meter per second. Okay, done. These two are our answers. So these are very, very easy examples and easy questions that come for this topic. Okay. Now we need to study further with another case. Okay, we'll just increase our knowledge or apply our knowledge in any case. Okay, in a given case. So right now we are studying an object. We are studying an object that is coming by a ramp. Okay. So let's say this is the ramp, or maybe a bit further. Yeah, inclining it further so that you might understand better. Theta. Okay. This is the ramp. Now bear with me. That's very easy thing actually. Let's say we have an object here, this red on. Okay. Now if we go to the geometry of this setup, we can easily go by the geometry. Say, let me draw a dotted line here. Okay. Now just bear with me. That's very easy thing. This one is theta. This one will be 90 degrees, right? This one is a right angle. So this one becomes a right angle triangle, right? This one becomes a right angle triangle. Let's say this is alpha. Now for any right angle triangle, what can you write? You can write that, or for any triangle actually, you can write the summation of all the angles sum up to 180 degrees, right? You know that. So summation of all the angles theta, 90 degree and alpha is 180 degrees. Now, so we get theta plus alpha equal to 180 minus 90 means 90 degrees, and we get alpha equal to 90 degrees minus theta. Okay. Now, if this alpha equal to 90 degree minus theta, see, if this alpha equal to 90 degrees minus theta, let's say we draw a perpendicular line to this inclined plane, okay, to this ramp actually. We draw a perpendicular line. So, are you seeing it? You should. So, let's check this one here. Let's check for this one. This here, this angle. As this is perpendicular, the summation of this angle and this angle will be equal to 90 degrees. So let's say this is beta. Beta, okay? So we are getting summation of alpha plus beta. So alpha plus beta equal to 90 degrees, okay? We get it very easily. Now, as alpha is 90 degree minus theta, so you might write that here, 90 degree minus theta plus beta equal to 90 degrees, okay? So the 90 degree gets cut from both sides of the equation. These are basically the same, 90 degrees and 90 degrees plus. So what we get here is minus theta plus beta equal to 0, right? So you get it, beta equals to theta. So that's the moral of the story we are working for here. See, for the first time when you are studying this, I am telling you this so that you get the logic. Okay? What is the logic here? What's the logic here? See, if this angle is theta, this angle, only this angle, okay? Which angle? This angle will also be theta. Beta equals to theta. So that's very easy. Whatever this angle is, this angle will be same. Let's say this is 30 degree. So this will be 30 degree. Let's say this 45. This will be 45. Let's say this 60. This will be 60. You can write it without even thinking about it from now on. Okay? So to do calculations very fast and easily in the examination, we won't write this thing anymore. Okay? We'll just write this as this is theta, this will be theta as well. Now, let's write it. So I'll just draw this ramp again. Okay, for you. And what we will do is that we'll just resolve the mg, or the weight of this mass, let's say this is mass S, mass M, so the weight will be mg here, okay? This is mg. This is mg. We will resolve it into two vectors that are perpendicular to each other, one in this line, okay, one in this line, and another one through this line, okay. Now, which one goes through this line? This one, right? So we will have a part of mg here, okay, we will have a part of mg here and another part of mg there, okay. So these two, these two has to add up to make this one, okay, logically. Now, see, what have we just learned? If this angle is theta, then of course, without much more consideration, you can easily say this is theta. Why? That was the logic there. So, see, this is mg, this one is mg. This one is the adjacent one, right? And this one is the opposite one. So, what we write for adjacent? Cosine of theta. What we write for opposite? Sine of theta. So, this is mg cosine of theta and this is mg sine of theta. Okay, done. Now, we calculated for mg. If we calculated for g, the gravitational acceleration, what would we get? We would get g cos theta here and g sin theta here. The adjacent one takes the cosine, the opposite one takes the sine. Very, very easy. Okay, so let's do one example here. See, this here, this taken from one of your textbooks. A freely falling object has a vertical acceleration of 9.81 meter per second square. Vertical acceleration means g, okay? So the value of g is given. If it's not given in the examination, you have to know that g is 9.81 meter per second square, and you know actually. The object is placed on a smooth ramp that makes an angle 30 degree up to the horizontal. See, why is it written smooth? Because there might be ramp with frictions, okay. For right now, for this course, right now, we have to consider it smooth, okay. That makes an angle of 30 degree to the horizontal. Calculate the component of the acceleration down the ramp. So, the component of the acceleration down the ramp. What is the component down the ramp? See, the component down the ramp is this one, okay. This one is down the ramp, and this one, if we draw this one, we shouldn't draw this one because it's not asked here. They asked us about this downward, okay. If we drew this one would be perpendicular to this ramp, not down the ramp, okay. So, see, that's very easy. This one is g, 9.81 meter per second square. So, see, it's given here, this is 30, so this one is 30, of course, okay. And this one is not adjacent to 30, this one is adjacent to this perpendicular portion of it, but it's not asked here. So, we have to get this one. Let's say this is AX. So, the AX, as this is the opposite one, so you have to write G sine 30. Okay, opposite to this 30. So, 9.81 and sine of 30 means half. So, you get 4.905 meter per second square. That's it. That's the answer. So, that's a very easy question, okay. Now, we have to study some more examples or just apply our knowledge to more examples. Like this is a sailboat, okay? This is a sailboat. Now, the man with the parachute exerts a force F to the sailboat, and the angle here, see the angle here given is 35 degree, okay? So what are the components of it? So the components will be towards this one and this one, right? These two will have to add up to this one. That's very easy. So this is 35, this is the adjacent one. So we get F cosine 35, and this is the opposite one. This is F sine of 35. Easy. Okay. For this one, this is 350 Newton, see? The force of the wind. So this angle given is 40 degrees. So what will be the components of it? So this one here and this one here, okay? See, that's very, very easy. This components will be shorter because you have to add up to this one, okay? So this is 350 Newton, and this is 40 degrees adjacent. So this will be 350 cosine of 40 degree, and this will be 350 sine of 40 degree, okay? Now you can do it yourself, okay? A crane is pulling a glider here. So this is 6.5 kilonewton, 6.5 kilonewton, okay? And this is 20 degree. So you have to get this and this. So this will be adjacent cosine, and this will be the opposite. Very, very easy topic, okay? If you see it easily, that's very easy. If you think otherwise or just complicate it yourself, it will be complicated. Don't complicate it. That's very, very easy. A tennis player hits a ball at 10 meters per second. See, the player is hitting a ball, say this way, it's 10 meters per second at an angle 30 degree to the ground. What are the initial horizontal and vertical components of velocity of the ball? See. So the velocity is how much? 10 meters per second. Now we need to get the components here, okay? This is the horizontal component and this is the vertical component, okay? So this is horizontal and this is vertical. Very easy. Now what is the angle? At an angle 30 degree to the ground. The ground is in the horizontal axis, right? So this will be how much? 30 degree. Now this is easy question. Okay, let's do it. Horizontal, it's adjacent. That's why it will be 10 cos 30. How much is it? 10 cos 30, 5 root 3 or 8.67 meter per second. And the vertical one, it is the opposite, 10 sin 30, 5 meter per second. Okay, done. Very easy questions. This is our final for this lecture. A water skier is pulled up a ramp. Okay, this skier, water skier, sorry for my pronunciation. Water skier is pulled up a ramp by the tension of a tow rope. Okay, so we have to analyze this very carefully. there is a pull from the tow rope, okay? It's pulling him. There is a force of 300 Newton acting horizontally. This is 300 Newton, okay? The ramp is angled at a 20 degree. So the ramp here is angled at, angled at 20 degrees to the horizon. What are the components of the force from the rope acting parallel to and perpendicular to the slope? Okay? So if you draw it here for the person, so the slope is here, see the slope, the slope is here, this is the slope, okay. Now we need to get two components of it, the parallel one, parallel to the slope. So we need to get this component, this one, and also the perpendicular to the slope. So this is the slope, let's write it here, this is the slope or the ramp, okay, and perpendicular. So this is perpendicular. So we need to get these two. So we are resolving this one to get these two, okay. Now what is the angle? See, this angle is, say, it's given 20 degrees, right? It's given 20 degree. So this angle and this angle is same, right? See it? See it, feel it. This is the same angle. So see, how much is it? 300 Newton. This one is the adjacent one. So for the parallel one, parallel to the slope, okay, this one is adjacent. So this will be 300 cos 20 degree. How much is it? Cos 20, this one is 281.91 Newton. And how much is the perpendicular one? (300 sin 20 degree). How much is it? 300 sin 20 degree, 102.61 Newton. Okay. See it, feel it, solve it. Okay. So that's it. So if I just summarize what we have learned today or in this lecture only, is that we need to, or we try to resolve this vector into two perpendicular vectors, so that if we add up this one and this one, we get R. Okay. So for this reason, we used the help of a right angle triangle, and we used sine theta, or the sine ratios and the cosine ratios. And these are the things that you have studied from your childhood. So for adjacent we need cosine of theta, and for opposite we need sine of theta. Very easy logics. And then we started applying this to our exam questions, to our maths and everything. And we did it successfully. Okay. We solved these questions, and these are the questions that come in your exam. Okay. In the next lecture, we will learn more about adding up vectors that are not perpendicular to each other, that are in a different angle to each other. Okay. For that time, I'll take a goodbye from you. Thank you.